In this video, I'm going to explain a little bit more detail about dilations, because how dilations behave on a graph is a little bit trickier than just reflections and translations. So in these examples, though, I'm just going to focus on vertical dilations or vertical stretches and compressions. That really should get you what you need in this focus area, or to answer the questions on the content assessment where you're identifying transformations from a graph. Horizontal stretches and compressions are pretty complicated, and I will explain that later when we're talking about what to do when you're writing the actual equation of a function given transformations, but here we're just going to stick with vertical stretches and compressions. So in this example, what we're going to do is we're going to take this original graph and we're going to do what it says: stretch by a factor of 2, compressed by a factor of 1/2. And the way I'm going to explain that, there's lots of different ways to explain this, but the way that I like to explain it is I'm going to put a couple of points here on our purple graph that are in the nice spot. So there's one. There's another nice one. There's another one. Always try and pick at least 2 or 3, but sometimes more. I'm going to do more on this one. I might do not as many on the next one, but just so that you can kind of see. So if I want to stretch by a factor of 2, what that actually is going to do, so stretching vertically, remember so stretching vertically changes things going up or down. So hopefully you'll remember, if I'm stretching or compressing vertically, that's going to change the vertical components of my graph. How I change those vertical components, like I said, there's a couple different ways to approach this, but the way I'm going to explain it to you is, let's take this point, for example. It is 1 unit away from the x-axis. That's the vertical component or vertical coordinate of this point, 1 unit above the x-axis. If I want to stretch by a factor of 2, that means multiply that distance by 2. So 1 times 2 is 2. There's my new point. If I do this one here, that point is 4 units away from the x-axis. Multiply that by 2, or double that, that takes me to 8. That's my new point there. Now this one, the one at 0, 0, it's 0 units away from the x-axis. 0 times 2 is still 0. So that's going to stay. This one, same thing, 1 unit away, 1 times 2 is 2. Now 2 units away. That one's 4 units away. 4 times 2, 8. So I'm going to do the best I can with this curve little tool that I can use on this program to connect these dots. It's not going to be perfect, but it should get us the idea. Okay, it's, like I said, not going to be perfect, but it's not too bad. Okay, so it's narrower than the purple graph. So you may not have to do this on the content assessment, but just so that you have some different words, so you know different words, if you see them in a context, you kind of know what they're talking about. So I would say this is narrower than the purple function. It takes each point and doubles its distance from the x-axis. That's what stretching by a factor of 2 does. Now let's talk about compressing by a factor of 1/2. So let me take these points, if I can. I'll just move that for now. Take these points and move them back to the purple graph, to our nice spots. And now I'll move that back. Okay. So if I want to compress by a factor of 1/2, What I'm going to do is I'm going to take these points and instead of multiplying by 2, I'm going to multiply by half, or cut in half the distance. So let's start with this point. That one might be the easiest to start with. It's 4 units away from the x-axis. Cut that in half, takes me to 2. This one, it's 1 unit away. Cut that in half. Come on. That takes me to half. Same thing here. Okay. Setting not to work with me. Okay, let's do this one. That's 4 units away. Half that is 2. There we go. Half 1 is half. So then my new function, after compressing it by a factor of 1/2, is it's going to be a little bit wider. There, that was pretty good. Almost perfect. So, compressing by a factor of 1/2 is going to make it wider, and each point is half the distance to the x-axis. Than the original. I just noticed that what I typed up here with narrower, that's why I paused for a second, makes no sense. Each point and doubles it, that makes no sense. I think I meant each point is double its distance from the x-axis. There we go, that's better. That was probably driving you guys crazy, but I fixed it. Okay. So, what I want you guys to take away from this is that vertically stretching and compressing occurs or is in reference to the x-axis. So it's extremely important, especially when I get to a problem like this, where the parabola or the function is not centered at the origin. So if I were to look at this one and go through the same process, although I'm not going to do it with as many points to kind of expedite the process here. So I'm going to do this one, and then that point, and then that point. At least I'm going to do these for the stretch part. So stretch by a factor of 2. Each point I need to double its distance from the x-axis. So if I start here at -2, double that distance away, here's at -4, or -2 times 2 takes me to -4. This is at 1, or -1. 1 unit away from the x-axis, double that, takes me here. Same thing here, double that, here. So I get something that's, what's it lost? Something that's narrower. I'm a bit of a perfectionist, so I'm going to try and fix it. Oh, that didn't really do anything. Come on. That's a little better. Okay, so narrower. If I compress by a factor of 1/2, move this out of the way, take these same points back. Again, I'm multiplying or taking the distance each point is away from the x-axis and cutting it in half, or multiplying it by 1/2. So this is 2 units away, half of that is 1, takes me there. This is 1 unit away, half of that is a half, takes me there. Same thing here on this side. Now these look like they're really, really close together, so it might be a good idea to take this point from the original function. That's 2 units away from the x-axis. Cut that in half, takes me there. And then same on the other side. So now I've got something that again is wider than the original. Okay? So as you're looking at dilations on a graph. Be very careful, because it's easy to just leave the vertex where it is and then stretch everything else. But that's not what you're supposed to do. It's all supposed to be in reference to the x-axis.